Assalamu alaikum. Today we're going to start our new chapter, Basic Geometry, on page number 162. Okay, first we're going to discuss the basic things. Basically, we're going to start from the importance of geometry. Why is geometry important itself, right? So you will ask yourself some basic questions here first. How do we build a house and a building, right? Yeah, of course we use bricks and stuff like that, but that's not what I'm referring to. I'm referring to geometry. When we're building a house, we have to be really careful about all the angles, okay? For example, just take a look around your house and you will see that your walls are mostly a rectangle or a square, right? They have to be. Why? Because if their angles are not properly 90 degrees, then the house will be distorted and there's a chance that it will collapse. So for the house to stand properly, the angles have to be precisely measured. And even in the floor, even if you go to the bathroom and look at the floor, most of the houses will have their bathroom floor slightly tilted towards the drainage system, so that whenever the water falls on the floor, it will slowly go towards the drainage system and the water will drain out. Why? Making use of angles. We're using angles, okay? Basically, that's what geometry is. Geometry is going to use all different kinds of shapes and different kinds of angles and all these things to make shapes and positions and sizes and different kind of planes. In different kind of planes, we're going to make these shapes and designs to properly construct a thing. For example, we have, for example, a house, for example, a building. To properly construct them without any errors in them, we use geometry. Even in the maps, if you look at the maps, it has units in them, right? And it is on a grid paper. Basically, maps are made on grids. And what are those grids? Those grids are a part of geometry. You take a look at roads. Roads have specific angles in them, really. Roads have angles. When you go on a mountainous road, the roads will be a little bit tilted like this. They will be tilted like this as they go around. And even if you go to the racing tracks, their tracks are also tilted. Why? To account for the centrifugal force that you will study about in higher classes. But the point is that even in making roads, you need to use geometry. What about designing bridges? This one is really important. Like, if there is even a slightest bit of problem in the weight distribution on a bridge, then it can collapse and a lot of people will die then. So you have to be really precise with your calculations while making a bridge, and for that, use geometry. Okay, now just take a look at your doors and the windows. They're what? Rectangles. Take a look at a ball. What is a ball? A sphere. Sphere means a three-dimensional um, ball thing, right? I'm just simplifying it. If you haven't heard about what a sphere is before, just take a look at a ball. Ball is in sphere shape, okay? Our earth is also in a sphere shape. It's like a round ball. The sun is also a gas giant, so like it's kind of a gas giant which is in a spherical shape as well. Now, another example for geometry is your mobile games and animation, the movies and dramas that you watch. They're all made from graphics, and those graphics are really precisely made for them to look good and appealing. You have to be really careful about the graphics, and the graphics, they use 3D motion systems which use basic geometry. Okay, honeycomb, it's an example of nature. Okay, take a look at honeycombs. They have precise hexagonal shapes in them. Every single one of them will be identical to make a perfect pattern, which we also call the tessellation. Okay, but the point is, it requires geometry. Okay, it's a kind of example of geometry in the nature. Then we have spider webs. It has precise angles. Each and every single one of the webs is at a precise angle from the other one, and that shows geometry. Then we have snowflakes. Snowflakes are also made with a precise angle. Even if you look at the atoms, okay, when you look at atoms, just look at crystals or crystal structure. What do you see in them? You see angles in them. This is true when you go into higher classes. You will study in chemistry the crystal structures, and in crystal structures they will have angles in them. If the crystal structure, for example, if one of the angles is different than the other ones, then the whole crystal shape will be distorted. It won't last. It won't stay compact the way it does in nature. So nature, there is a lot of examples of angles in nature and a lot of examples of geometry in nature. Okay, another example is that our planet is of spherical shape, and when we're dealing with shapes, that is basically geometry. There are lots of formulas that are specifically for a sphere, and it doesn't really matter if the sphere that we're talking about is a ball or if the sphere that we're talking about is a planet. We can apply those laws. For example, let's just talk about the area of a sphere. We have a formula for the area of a sphere, right? We can use that formula for a ball, and we can use that formula for the entire planet as well. Doesn't really matter. Then again, orbits are in circles or oval shapes. They have their own formulas and they're related to geometry. Then we have constellation of stars. Basically, stars making specific patterns in the space. That's what we call a constellation. And those constellations are basically also following a specific pattern, a geometrical pattern. And that also shows how important geometry itself is. Now, it doesn't really matter whether you're going to become a scientist or not in the future, but these things are really important for you to understand the surroundings, your life itself. Geometry is really just that important, so make sure you fully focus on this chapter from the start. It'll be easier that way. Okay, we're going to start with the basic definition of geometry. You can see, you can also read it, the one that is written in the book. We're going to explain the one written in the book, but first let's talk about a simplified version. Geometry, it is a branch of mathematics that deals with shape, size, position, and space. What does that mean? That means you do understand what shape means, right? Figures, basically. So geometry deals with figures, their sizes. For example, we have a small circle, we have a big circle, all of their sizes. Geometry deal with that. And the position. Now, what does position means here? You're going to study about this position thing in a lot greater detail when you're studying planes. Okay, position basically means where is it located in a piece of paper or in space. Where is it located? The location of that shape or thing that we're talking about in geometry, that is going to be discussed in positioning. And how are we going to describe its position? In grade 4th, we studied basically. We studied translation, and what was the purpose of translation? It was to show how an object is moving in a plane surface, right? On a plane surface. And we also talked about rotation, transformation, right? All of them were for the purpose of showing translation. Okay, when we were talking about translation, we said an object is on one specific point and it's being translated to another specific point, right? What was that point? That point showed its position. Okay, position is your location at one point. For example, if you go to the Google map, it will show you your coordinates, those random numbers that we have here, right? So those numbers, they're your position in the globe. Okay, for now, just understand that the position basically means the location of the shape, and space means a three-dimensional area, or you can also say it's two-dimensional, but it basically means the area available or the space available. Basically in 3 dimension, it's going to be a little bit of a higher class level stuff, so we're not going to discuss that much in details. For now, just understand that space means the allocation that you have in the plane surface that you're given. Okay, in geometry we study shapes. It is just as simple as that. We will study figures, okay? Their types, the types of shapes we have, and basically the definition of shapes, and how are we going to deal with the shapes, what are the rules for the shapes, what patterns do the shapes follow, the kind of you see, there are a set of rules, the set of definitions, the set of the basic ideas that we're going to study in this chapter, which is kind of similar to what we said about algebra. We said algebra is the study of rules, right? So basically, yeah, we're going to do some similar stuff here as well. Relative position of figures. Relative position, relative means relative positioning of a figure means, for example, I have this point, right? And I'm talking about this random shape. So if I describe this position of this shape with respect to this point, then that means I'm talking about its relative position. Okay, its relative positions means its position relative to this dot. Okay, if I talk about the location of this rectangle with respect to this random shape, then I'm talking about this relative position of this random shape. Okay, it's not going to be really that much of a use in our for now at our level. We're not really going to go into the details of positioning right now. For now, just focus on the fact that we're going to deal with the study of shapes in this chapter. Okay, the properties of space, that also isn't really much of your level for now, so that's why I gave you guys a simplified version of this definition. The book deals with a lot more. Yeah, geometry is a lot more complicated than this, what I wrote here. But basic understanding is this, that geometry is a mathematical branch that deals with shape, size, position, and space. For now, at your level, this is what you need to know. Okay, once you're done with that, now we need to talk about point. In this chapter, for now, you don't have to write these things. Okay, you don't have to write them. If you think this is important for you, if you think this is a more simple version of this, if it's a simple definition, then you can write this down, but you don't really have to for now. Okay, the rest of the things are also given in your book, and we're gonna focus on explaining what is written in the book. Okay, for now, first of all, what is a point? Point is the most basic geometrical figure. Okay, there is nothing really much of in great detail about this. Point is just simply a point. Again, point, the few things that I want you to remember about a point is that it has neither the size nor a shape. Okay, point doesn't have a size. So if you tell me how much long this point is, I can't say anything. Okay, if you tell me to tell you how thick a point is, I can't tell you that, because point doesn't have a size. It doesn't have a shape as well. It's not circle, you can say. Point is just a point. Okay, dot is a circle kind of thing, but point is just a point. It's the most basic geometrical figure. One more thing that you need to know about a point is that point can be represented with a dot and a cross. Okay, not only a dot but a cross as well. This cross, it's also a point, and this dot, it's also a point. Okay, so both of them are being used to symbolize a point. Then again, when we're talking about a point, we're going to use capital letters to name the point. Okay, this is the third point that you really need to remember, is that whenever you're naming a point, you're going to use capital letters to name it. Okay, so this is point A, capital A. Okay, and this is capital P. Now, one more thing that you need to remember here is that everything in geometry is built using these basic ideas. What basic ideas? Basic idea of point, lines, and all the types of lines that we're going to study: intersecting line, perpendicular line, parallel line, planes, and all the things that we're going to do in this chapter. They're basic level. Okay, and these are the basic ideas that are required for us to make shapes and for us to basically do anything in geometry. We need to know these things. Okay, then we are talking about lines. Now, lines have basically three different types we're going to deal with. First of all, the line itself. Second of all, the line segment. And third of all, the ray. Okay, ray. What is a line? Line is when a line segment continues in both direction indefinitely. If it is going in this direction indefinitely and it's not stopping, then that means it's a line. Okay, by definition, line is endless. Line goes to infinity by definition. Okay, what is a line segment? Line segment have endpoints. This means that it ends here and it ends here. It ends at point A and point B. That's it. This line does not continue indefinitely, and that's why it's a line segment. It stops here and stops here. You can also say that this is a starting point and this is an ending point for this line. Okay, or this is the starting point or this is the ending point. It's your choice, but the point is that it ends. This doesn't continues forever. While a line will continue forever. Line segment will never continue forever. So in other words, in simple words, you can measure a line segment because it has a specific length. It stops. It doesn't continue forever. But line, you cannot measure a line because it continues indefinitely, forever, endlessly. Okay, one more thing is that you can use arrowheads. You can use arrowheads to show the direction in which the line is going to continue indefinitely. In this one, we didn't make any arrowheads. It's still fine. You don't have to make the arrowheads, but it's preferable to make the arrowheads to show that this line is going to continue indefinitely in this direction. Okay, arrowhead here to show that it's going to continue indefinitely in these two directions. Okay, now we're going to deal with ray. What is a ray? Ray is when you have one ending point, but the other point is continuing indefinitely. Okay, it has a starting point. And it continues indefinitely. That is a ray. If it has two ending points, then that means it's a line segment. If it has no ending points, then that's a line. And if it has one ending point, then that's a ray. Okay, just like sun rays. Sun rays originate from the sun and they continue on in space until they hit the surface, right? So they are ray. Okay, starting point, they have a starting point, or you can say they have an end point, but they don't have the other point. It just continues indefinitely in one direction. So that's a ray. You need to memorize these definitions. Okay, you need to memorize these basic definitions. Now we have intersecting lines. Basically, when you have two lines that cross each other or go through each other, that's intersecting lines. Okay, our purpose right now is to understand the word intersect. Okay, when you have this common point between two lines, and that means they are intersecting, and the point where they are intersecting is called the point of intersection. Okay, this is important. Remember these things. Okay, then you have perpendicular lines. Whenever two lines intersect, okay, I am using the word intersect again, they intersect each other, means they cross each other in such a way that in one point they have a right angle. That means those two lines are perpendicular to one another. Okay, in very simple words, you can say line AB and line QP, they are intersecting one another at a right angle. The angle between them is right. Okay, so that's a perpendicular line. This is the symbol. The inverted T is the symbol for perpendicular. So we're going to say AB is perpendicular to PQ by using this symbol. Okay, remember this symbol, it's really important. F is known as the foot of the perpendicular. Basically, the point where they are, where we have the perpendicular, is known as the foot of the perpendicular. Okay, when two intersecting lines form 90-degree angle at a point of intersection, they are called perpendicular lines. This is again a very simple definition of perpendicular lines. When two intersecting lines have a 90-degree angle at the point of intersection, they are perpendicular. Okay, one more thing that you need to remember is that the lines don't have to be perfectly cutting each other in the middle. Like this example, they can be on the sides, it doesn't matter, as long as they have 90-degree angle between them. And what does this square represent? This square represents a 90-degree angle. Okay, here we have a small square, we have a small square, we have a big square. It doesn't matter. Okay, the square size doesn't matter. It just is there to it is just there to signify what? A 90-degree angle. Okay, it's a symbol for 90-degree angle. That's it. It is nothing more than that. And in this example, we have two lines that are intersecting at an end point. Okay, they don't continue indefinitely. We have line segments. These are not lines, these are line segments, but they are also making a 90-degree angle between them. And that means these two line segments are what? They are perpendicular to one another. So we don't only have perpendicular we don't only have perpendicular lines, we also have perpendicular line segments. Okay, or it can be maybe in perpendicular rays, but the understanding, what you need to understand here is perpendicular. The word perpendicular. Okay, it means that whatever we're talking about, whether we're talking about lines, whether we're talking about line segments, they will have a 90-degree angle between them. Then you need to understand parallel. What is a parallel line? Parallel lines, basically two lines that will never intersect. Okay, that will never intersect. A very simple example for this is that, for example, I have these two lines. Imagine these two lines. Okay, they are not intersecting right now. What I'm holding, okay, they're not intersecting right now. They're intersecting right now, but they're not intersecting right now. But I know that if they continue to go in this direction, at one point they will always intersect. Okay, let me show you an example. I have this line and I have this other line. These two lines are not intersecting right now, but they're not parallel. Why? Because I know these two lines will continue indefinitely, and if I show them continuing, look, there will be a point in future where they will intersect. There will be a point in future where they will intersect. Parallel lines are such lines that no matter how far and wide you go, it doesn't matter, they will never ever intersect. Take a look at these two examples, right? This will continue onwards in this direction and this will continue onwards in this direction, and they will never ever intersect with one another. These two are parallel lines. Okay, one more thing that you need to remember here is the symbol. Okay, the symbol for parallel is two straight lines, basically, you can say. So if I say AB is parallel to CD, I will write it like this. Okay, two straight lines. This is a symbol for parallel to. Okay, so AB is parallel to CD. AB is parallel to CD. This is parallel. Parallel says something about two lines lying on the same plane. We need to understand what plane is now, okay, for us to properly understand parallel. And we have a plane here, right here. Basically, plane is a flat surface. Plane is a flat surface. It's a two-dimensional surface. We have a length here, we have a breadth here, but we don't have thickness. What does that mean? That means a flat piece of paper or a screen. You have mobile screen, you have video table, you have video game screens, you have a laptop screen or desktop screen, you have your TV screen. All of these are flat surfaces, and all the things on them, for example the picture, the movie, all of them are two-dimensional. Okay, in the book we have this page, it's a flat surface. On the page we have this drawing here, we have these words here, all of them are two-dimensional. Okay, so it's a plane. Plane is a flat surface with only two dimensions. Two dimension, what does this two dimension means? It means it has a length, it has a breadth, but it doesn't have the thickness. What does this thickness means? Okay, let's take this book for an example. Let's take this book for an example, right? It has length, this is the length, it has breadth, and then it has thickness, how thick the book is. Okay, a two-dimensional plane doesn't have thickness. It will have length. Okay, length, for example this book has a length, it has a breadth, it goes like this, but it doesn't have thickness. Okay, it shouldn't have thickness when you're talking about plane. Okay, plane is a flat surface. Then an example for the plane, you have your horizontal plane is like, you can look at the floor of your house. If you're in home or wherever you are, just take a look at the floor. That is basically an example of a plane. Okay, you can take a look at the wall, that's an example of a vertical plane. Okay, what does vertical and horizontal means? This is also something that you really need to remember. Vertical means up down. Okay, something that goes up and down, that's vertical. And something that goes left to right or right to left, that's horizontal. Okay, so when I say horizontal lines, I mean the line that goes left to right, or when I say vertical lines, I'm talking about what goes up and down. You need to remember these basic ideas and concepts to be able to deal with other things in geometry. Okay, now One more thing that you need to remember about planes, okay? It's written right here. Point A, X, B are collinear, i.e. they lie on the same line. However, point PX and B are not collinear, okay? What does that mean? Basically, we have point A, X and B. We have them in the same line, okay? They are on the same line, and that means they're collinear. Co means same, or you can say they're in cooperation. You can say linear is related to line, right? Linear means line. So collinear, they're on the same line, A, X, B. So they're collinear. But PXB, 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 they are non-collinear. Why? Because PX is on a different line, and then B is on a whole different line. B is on AB line and P is on PQ line. So P and B are on different lines. That's why PXB are non-collinear. That's all that you need to know for now and related to parallel and planes. Okay, now we're going to go towards angles. Okay, angles. How are we going to define angles? What are angles? What are their purpose? Why do they exist? Okay, basically, first of all, whenever two line segments or two rays, they have a common point, or they intersect. Whenever two lines or two line segments or two rays intersect at a point, they will make an angle. Okay, intersection basically will make a vertex. What is a vertex? Vertex means a corner. Vertex means corner, basically. Vertex of an angle means a corner. For example, we have this line, we have this ray and this ray, because they have an endpoint here and they're continuing indefinitely in this direction. So we have a endpoint here. That's why they're rays. Okay, and these two rays, they have this common point. This common point is the vertex. You can also call vertex a corner. Okay, why am I saying it's a corner? Okay, we were discussing angles, right? We were talking about vertex being a corner. Okay, and it can be a line segment too. It doesn't only have to be rays. Angle can be in between line segments. Okay, it doesn't only have to be rays. One more thing is that the angle is always in between either two line segments or two rays. Okay, in between two line segments I will always have an angle. In between two rays I will always have an angle. Okay, what is angle by itself? Okay, one more thing, that I can call those two rays two sides or arms as well. Okay, or two line segments that I have, I can call them sides or arms. See them, we have OB and we have AO. They are what? They are two arms as well. We can call them arms. Okay, and what is the definition of angle? Angle is how much one ray is turning away from the other one, or basically angle is the measure of turn. How much turn is happening. That is what angles are. Okay, angle is basically the measure of turns. And how do we measure angles? We use units of measurement for angle is what? Degrees. We use degrees. Okay, what degree is, we're going to come to that later. First of all, we need to talk about symbols of angles. Okay, we have this symbol. This is the symbol for an angle. Okay, for example, angle A, we're going to write it like this. Okay, this is the symbol for an angle. Or you can also say the name of angle as its symbol. Okay, for example, AOB can be written as, angle AOB can be written as this symbol with the letters, or you can also use this symbol for the angles. How are we going to name angles? How are we going to name angles? Look at this. Look at a few examples that I have made here. First of all, look at this. It's a rectangle. Rectangle have how many corners? 1, 2, 3, 4. A rectangle has 4 corners. This is by the definition of rectangles as well. Rectangles will always have four corners, and rectangles will always have four sides. 1 2 3 4, four sides and four corners. Okay, look at this corner, it has a 90-degree angle, it has a 90-degree angle, and this one also has a 90 and a 90-degree angle. Okay, these are the corners of a rectangle, and they have 90-degree angles in them. Each and every single corner, wherever there's a vertex, there always will be an angle. Okay, wherever there's a vertex, there is an angle. Here we have a vertex, so we have an angle which is 90 degrees. Here we have a vertex, but this angle is not 90 degrees. Now we're talking about a triangle. How many angles does a triangle have? 1 2 3. A triangle has 3 angles on the inside. Okay, because it has 3 vertices. 1 2 3 vertices. Okay, now I'm gonna name these angles. Okay, first of all, I can denote an angle by using small letters, small alphabets. Okay, so I named this angle small a, or small b, or small c, d, e, f, g, h, I, j, doesn't matter, but as long as it's small letters. Okay, so I can use the symbol with a, use the symbol with b to denote this angle, use the symbol with c to denote this angle. Okay, one more way of naming these angles is using the letters. Okay, capital letters. How we're going to do that? We're going to use the line segments. Okay, first of all, in the middle will be the vertex. In the middle will be the vertex. For example, let's talk about angle A. Angle A, and what is the vertex in angle A? Point A. So that's why A is going to be in the middle, and B and C are going to be the other sides. For example, take a look at this. C, A, and B. This is basically making angle A. That's why it is called BAC. You can also call it CAB. It doesn't matter as long as A is in the middle. Okay, the important thing is for A to be in the middle. It shows that A is the vertex where angle A is present. Okay, angle B. So B is the vertex, and A and C are the sides. A and C are showing the sides. You can also call it CBA, ABC, or CBA, as long as B in the middle. Okay, we have ACB and we have BCA. Again, I wrote the first form, then I inverted it. Doesn't really matter as long as C is in the middle. Okay, to show that C is our vertex. This is the way you name an angle. Okay, once you're done with naming the angles, you need to understand degrees now. What is a degree? Degree is how you measure an angle. Okay, for example, degree, what is the definition of degree itself? Degree is defined as 1/360th of a complete revolution. What is a revolution? A turn, a complete turn. What does a complete turn means? For example, I have this with me. It's like this right now. Okay, I turn it and I turn it. It completed a whole complete turn. Okay, that means it covered 360 degrees. 360 degrees means starting from a point, turning until you're back to the first position that you were in. For example, if you just stand up right now and start turning left, then again left, then again left, a point will come where you will face the same direction that you were facing in the start, and that means you completed the turn, and that means you covered about 360 degrees. Okay, when one complete turn is divided into 360 parts, each part is going to be of 1 degree. Okay, and that shows one complete revolution of about a point is 360 degrees. Now this statement you need to memorize it. Okay, that a complete revolution around a point, for example, I have this point, I'm going to complete this entire revolution around it, then it's going to give me 360 degrees. For example, take a look at the clock. You have clocks. I'm talking about conventional clock, not a digital clock. If you take a look at the clock, the hands of the clock will start from 1 o'clock, let's just say from the start, 1 minute, 2 minutes, 5 minutes, 10 minutes, 15 minutes, 30 minutes, all the way to 45 minutes, and then 1 hour completed. When 1 hour is completed, that means one complete rotation happened. This is also a 360-degree turn that the hand of the clock made. Okay, now how are we going to measure angles? How are we going to measure angles? We're going to measure them using a protractor. Okay, it's not a protector, it's a protractor. This tool, we can measure an angle using this tool. How are we going to measure an angle using this tool? First of all, you need to understand what the center is and what a baseline is. Center is going to be the vertex or the point of intersection of the two rays. Point of intersection of the two rays or line segments. Okay, this is going to be the center. For example, I have this tool right here with me. This tool. The center of this tool, this blob thing that we have here, this is the center, and we're going to place it right on the vertex. Okay, that's the first rule that we need to follow while measuring angles. For example, I need to measure this angle. What am I going to do? I'm going to place it right on the vertex. Okay, my center of this protractor thing is going to be on the vertex. Then I need to make sure that you have this line here, right? I'm talking about this line that goes on the bottom here. This line will be on the baseline. Okay, this line will be on the baseline. What does baseline means? Baseline is basically any one of the two arms that you have selected as your base. Any one of the two arms that you have selected as your base. For example, in this angle, this can be my base or this can be my base. Okay, if I want to measure this angle, what am I going to do? Place the center on the vertex. Okay, the baseline on the arm, and then I'm going to measure it using the other one that we have. For example, this is about how much? It's about 120 degrees. This angle is. Okay, the other thing is this rule that you need to remember. It's that when a baseline is towards the left, for example, this baseline, in which direction is it going? It's going towards the right direction, right? So that's what I mean. When baseline is towards the left, you will use the outer scale. When baseline is towards the right, you will use the inner scale. What do I mean by inner and outer scale? Take a look at this, right? You have numbers going on the top and you have numbers on the bottom. You can look at your book as well. It has numbers on the top and it has numbers in the bottom. This is the outermost is called the outer scale and the innermost is called the inner scale, right? So when are you going to use the inner scale? When you have the baseline going towards the right. And when are you going to use the outer scale? When you have the baseline going towards the left. Right now it's going towards the right. That's why I'm going to use the inner scale. In this case, for example, I turn the page. Now this baseline is going towards the left. It's going in this direction, which is left. Then if I was to measure it using this arm, I will use, okay, see, it's 120. It's 120 here. I will use the outer scale for the if the baseline is going towards the left. Now you can also use your common sense. What do I mean by that? You know what an acute angle is, right? You know what an acute angle is, you know what an obtuse angle is. You've done this in previous grades as well. So what does this look like? Even if I don't measure this angle, I know just by looking at it that it's less than 90 degrees. It's less than a right angle. So I can easily say that whatever this angle is, it's going to be less than 90. It's going to be either 60 or 45 or 50. It doesn't matter. Whatever it's going to be, it's going to be less than 90. So the numbers that I'm going to use in this tool are going to be less than 90. Now I placed it. I'm going to measure it. One scale says that it's 130. The other scale says it's 50. Just think about it. If it's an acute angle, then obviously it's going to be less than 90. Then that means I cannot say it's 130. It's going to be 50. If you just remember that, you will not be getting these calculations wrong and measuring the angles wrong. Okay. Now just take a look at this one. It's obviously more than 90. Okay. So it's an obtuse angle. So whatever this angle is, it's going to be more than 90. So if I measure it, and if I forget the rule of which scale am I supposed to use, just think about it. Okay. One says it's 60, the other says it's 120. Obviously, since it's an obtuse angle, so it's going to be more than 60. That's why I'm going to use the inner scale, which says it's 120. Now this one, obviously it looks like it's more than 180. It's more than a straight line, so it's more than 180. And when I'm measuring that, I won't have to bother about which scale am I supposed to use. Just knowing whether it's an obtuse angle or an acute angle, it's enough to tell me which scale am I supposed to use. Okay. Hopefully you know how to measure an angle now. This is something you are supposed to do in grade 4. Okay, now types of angles. It's just really simple and really basic. Acute angle we have right angle, we have obtuse angle, and we have reflex angle. What is an acute angle? Whatever is more than 0 and less than 90. Okay, what is right angle? Exactly 90 and only 90 is going to be a right angle. What is obtuse angle? Whatever is more than 90 but less than 180. Okay, so this is more than 90 but less than 180, then and only then it will be obtuse angle. Then we have reflex angle, which is going to be more than 180 but less than 360. Okay, it doesn't matter if it's it doesn't matter if it's 200, if it's 270, if it's 300, as long as it's less than 360 and if it's more than 180. Okay, then and only then it'll be a reflex angle. Now focus on this definition. What if the angle is 89? If it's 89, then it's still less than 90, and that's why it'll be acute. What if the angle is 1? 1 is still more than 0, that's why it'll be acute. What if the angle is 91? If it's 91, then it's more than 90, and that's why it'll be obtuse. What if it's 179? If it's 179, then it's less than 180, that's why it'll be obtuse. What about 180? If it's 180, then it doesn't come in acute or it doesn't come on obtuse or reflex. Okay, if it's 180, then it doesn't come in either of these definitions. 180 is basically just a straight line, so it has to be 181 for it to be a reflex angle. Okay, now you can do the practice. Okay, now we're going to talk about what are complementary angles. Okay, basically the first and the most important thing that you need to remember here is that two angles, they will always be only and only two angles. Okay, two angles are known as complementary angles if they add up to 90. So it doesn't matter whatever those angles are, if their sum is 90, then they are going to be complementary angles. For example, I give an example here. 30 plus 60 is 90, and that means 30 degrees and 60 degrees are complementary angles with each other. Okay, what about 10 and 80? Their sum is 90, that's why they're complementary angles. Whenever the sum is 90, that means complementary angles. Just as simple as that. There's nothing more about it. 50 plus 40, 90, that's why they're complementaries. 62 plus 28, their sum is also 90, that's why they're complementary angles. Okay, what about supplementary angles? Supplementary angles are again only and only two angles. Okay, we're not talking about three angles, we're not talking about one, we're not talking about four. It's only two angles. Okay, two angles in such a way that they add up to 180. In other words, whatever those two angles are, if their sum is 180, then that means they are supplementary angles. Okay, for example, 90 plus 90, 90 is its complementary angle, then supplementary angle. 90 plus 90 is 180, that's why 90 is a supplementary angle with 90. What about 170 plus 10, right? 170 plus 10 is 180, that's why they are supplementary angles. 179 plus 1 degrees is also 180, that's why they are supplementary angles. It doesn't matter whatever those two angles are, as long as their sum is 180, they're going to be supplementary angles. Okay, and they have to be two angles. Just remember that they have to be two angles. Okay, in this and in this, both of them, they have to be only two angles. Okay, and if the sum of those two angles is 90, then they're complementary. If the sum is 180, then they're supplementary angles. That's it. Now we're going to talk about angles on a straight line. This is really important. This is something you did in grade 4. Grade 5. Yeah, this is something you did in grade 5. What does that mean? It says that, first of all, before doing angles on a straight line, we first need to understand what adjacent angles are. Adjacent angles always are on a straight line. Okay, first of all, adjacent angles on a straight line, they have a common vertex, they have a common side, and they lie on the opposite side of a common side. Another thing that you need to know is that adjacent angles are a pair of angles that share a common vertex. Okay, the most important thing here is a common vertex. For example, take a look at these: angle x, angle y, and angle z. They have a common vertex, which is O. Okay, their common vertex is O. They share a common vertex, and they also share the common side. For example, x, for example, y, they're sharing a common side. That's why x, y, and z are adjacent angles. And what does it mean? What does this statement is the most important statement that you need to remember here. Okay, the sum of adjacent angles on a straight line is 180. So as long as you have a straight line, whatever those angles are, doesn't matter, their sum is going to be 180. The end of the story. That's it. You need to remember this, you need to memorize this. Okay, whatever those are, it doesn't matter how many angles you have. For example, you have 2 angles, you have 3 angles, you have 4, you have 5 angles. Whatever they are, if they are on a straight line, then their sum is going to be 180. Okay, we're going to do this in a lot more detail when we're doing the exercise, but for now, remember this: sum of adjacent angles on a straight line is 180. Sum of adjacent angles on a straight line is 180. Repeat this again and again until you've memorized it. Okay, adjacent angles have one more thing about them that you need to remember: adjacent angles do not overlap. Okay, adjacent angles do not overlap. For example, in this example, you can see that A and B, they don't overlap. They are totally different from one another. That's why they are adjacent. They can be adjacent. But take a look at these two A and B's. These ones, they overlap. B also is made up of A and some other angles, right? B is made up of A and some other angle. That's why B is overlapping with A. This means A and B in this case are not adjacent. Okay. In this case, yeah, A and B will be adjacent. Okay. In this case, A and B will not be adjacent. What does adjacent side means? Adjacent sides means a pair of sides that share a common vertex. Adjacent basically means near to something or close to something. So when you see adjacent, basically means they're near or close to one another. Okay. Opposite, on the other hand, means that it's far, or you can say it's on the other direction or different. Now, do we know A and B? No, but we know that their sum is going to be 180. That's it, the end of the story. You can just take a look at it and tell that you don't know what A is, you don't know what A is, and you don't know what B is, but since they are on a straight line, and that means they're covering half of a circle, and half of a circle is 180. That's why their sum is going to be 180. Then we don't know what X is, we don't know what Y is, we don't know what Z is, but if I add them all together, their sum is also going to be 180. Okay, just take a look at it and you'll be able to tell. Now, in the worked example, what's happening here? Basically, let's do practice. Okay, what did we do here in practice? The practice says 122. Okay, one of the angle is known and the other one is missing, and they are on a straight line. Okay, AOB, this is a straight line. AOB is a straight line. One of the angle is known and the other one is unknown. So we know that sum of these two angles is going to be equal to 180. Sum of these two angles is going to be equal to 180. So I can say 122 plus A is going to be equal to 180. And when you solve it through a linear equation, then you will be able to tell that 180 minus 122 is equal to 58. In this question, we have two of the angles given and one of them is missing, and we know that they're on a straight line, so their sum is going to be 180. So what are we going to do? We're going to add the given angles and we're going to subtract them from 180 to find the missing angle. Okay, in a lot of questions you're going to do the same thing. You're going to do what? You're going to add all the given angles and you're going to subtract them from the total, which is 180 in this case, to find the missing angle. Okay, we have figure number 2. Figure number 2 is a bit more interesting. Here we have 2c and we have 3c. We don't know what c is, but we know that this angle is 2c and this one angle is 3c and this one is 100. Okay, we know that sum of all of them is going to be equal to 180. So I say 180 is equal to 100 plus 2c plus 3c. Basically the sum of all three angles is equal to 180. Now 2c, 3c, they are same variables, that's why they're going to add each other. They're going to add with each other, and 2c, 3c will make it 5c. 100. Okay, now we have a constant. The constant goes from this side of the equation to this side, or you can say I subtracted 100 on both sides of the equations. 180 minus 100 will give us 80, and 80 divided by 50 will give me 16. So the value of c is 16. Once I know the value of c, I will be able to find what 2c is and what 3c is. Okay, 2c is going to be 32 and 3c is going to be 48. Okay, and a lot of questions are going to be like that. Now, before doing more examples and more stuff related to the angles on a line, we're going to deal with angles at a point. Okay, we have one more thing that you need to remember. This is really important. Again, the sum of angles at a point is 360. Sum of angles at a point is 360. So if you see a point of intersection and you have angles around it, all of them, when you add them together, they will be 360. This is the rule. Okay, I said we're going to deal with some rules in this chapter, right? These were the rules that I'm talking about. You have complementary angles, and the rule is that it adds up to 90. Supplementary angle, the rule is that it adds up to 180. We have angles on a straight line. The rule is that whatever and however amount of angles we have doesn't matter, but their sum is going to be 180. Same goes for angles at a point. Their sum is going to be 360. This is a rule. You need to memorize it. The sum of angles at a point is going to be 360. Okay, now we're going to understand it by using an example. Okay, take a look at this example. We have 4a, we have 50, and we have 124. Now we know that their sum is going to be 360. So that's exactly what the book does. It added them together. 4a plus 50 plus 24 plus 214 is equal to 360. Now since 50 and 214 are constants, they're going to add with each other up, and you can then subtract them from 360 to find the value of 4a. Once you know 4a, you can divide 4 on both sides of the equations to find the value of a. Okay, and that's the whole question, to find the value of a. Similarly, we're going to do, I did practice 3 here so that we can understand it more properly. What does this mean? The sum of angles at a point is 360. To understand it in greater detail, I did this practice here. Now I'm going to explain it. Okay, first of all, take a look at this. We have how many angles? We have 3 angles. One of them is 148, the other one is 7a, and the other one is 58. We're going to add them all up together, and then we're going to subtract the sum of these two from 360. We will be able to find the value of 7a, and then I'm going to do what? I'm going to divide 7 on both sides to find the value of a. This is easy, so you can do this by yourself and find the answer. Check it from the book. Okay, we're going to do B part here, the second question of practice number 3. Take a look at this. Which says B, we have one angle which is B, we have another angle which is also B, we have another angle which is 4b, and another which is a square. What does this square means? 90 degrees. Okay, so all the angles are given here. What am I going to do? I'm going to take each and every one of them, I'm going to add them up, and I'm going to say that they're equal to 360 because they're all around a point. Okay, so B plus B plus B plus B plus 4b plus 90, they all make 360. Now since b and 4b are same variables, that's why they're going to add up to make 6b. B plus b, 2b plus 4b makes 6b. Okay, 6b plus 90 is equal to 360. Now I'm going to subtract 90 on both sides to get 6b is equal to 270 degrees. Okay, divide 6 on both sides to find the value of b, which is equal to 45 degrees. Okay, now since we know the value of b, we can easily find what 4b is. But the question doesn't even ask us to do that. I just did an extra step to know what the angles were. This is 4b. It looks exactly like that. Look, it's a straight line. It's an angle on a straight line. So of course it's like a semicircle. So it's going to be 180. Okay, now one more thing that we need to do before we can start our exercise is that we need to understand vertically opposite angles. Okay, whenever you have two straight lines, okay, two straight lines or two straight line segments or two straight rays, whenever you have two of them, okay, and they are straight, they are intersecting at a point, then you will have a pair of angles, basically two pair of angles, and they're going to be vertically opposite angles. What does that mean? Take this line, it's a straight one, right? I have another line which is straight, and they're intersecting at a point, making four different angles, right? Now A is opposite to B and C is opposite to D. What does it tell us? What does this tells us? We have another rule here which says vertically opposite angles are equal. So it doesn't matter what C is, it will always be equal to D. And it doesn't matter what A and B are, they will always be equal to one another. Now, one more thing that you need to remember here, or you can take a look at, is that, for example, I'm going to cover this up. What does it look like? It's a straight line. It's a straight line. And what do we know about a straight line? We know that the sum of all the angles on a straight line is going to be 180. Sum of all the angles on a straight line is going to be 180. So that means A plus C is going to be equal to 180. I can do this. That means A plus D are going to be, A plus D is also going to be 180 because they're on a straight line. Okay, I can also do this. We have B and D, they're also on a straight line, then that means their sum is also going to be 180. So that means we know a lot of things here. Now we are able to tell that A and B are same, A and B are same, and C and D are same because they are vertically opposite angles, and the rule says that vertical opposite angles are always equal. Vertically opposite angles are always equal. One more thing, sum of A, B, C and D is going to be 360 because they are around a point. They are the angles around a point. So effectively I applied all three rules that we just memorized recently. Vertically opposite angles are going to be always equal. Angles on a straight line are going to be sum of all the angles on a straight line is going to be 180, and sum of angles at a point is 360. These three rules are really important. Okay, now one more thing that you need to remember is that, take a look at this. Examples of angles that are not vertically opposite. This line is not completely straight. It goes like this and then it turns away a little bit. That's why A and B are not equal to one another. Even though they are opposite, but they're not equal to one another because we only have one straight line. And here we don't have any straight lines. One goes like this and the other goes like this. This one goes like that. We need two straight lines intersecting, okay? And at their point of intersection, we will have angles which are going to be vertically opposite angles, okay? And those vertically opposite angles are going to be equal to one another. Now, I did example number 5 so that we can understand it better, and example number 4 here as well. Okay, the book says A and B is a straight line, okay? I'm going to use this again to show that, yeah, they are a straight line. See, A and B, it's a straight line, just like the book says. Then we have C and D, which is again a straight line, and the angle between them is between A and C. Look, this and this angle, they're going to be same. We don't know them yet. I found them, but we don't know them yet currently, right? But they're going to be same because they're vertically opposite angles. Then whatever this is, it's going to be equal to this because they are also vertically opposite angles. Now we know that angle AOE, they are 90 degrees and DOE is 53. That's the only piece of information given to us. That's the only piece of information given to us, that this angle is 90 and this angle is 53. We know that sum of all the angles on a straight line is 180, right? Sum of all the angles on a straight line is 180. So what are we going to do? We're going to add 90 and we're going to add 53 to find the missing angle. Right now we don't know this one, right? We're going to add them to find the missing one, which is going to be, okay, when we add them we will get 143, and when we subtract 143 from 80 we will find that it's equal to 37, right? So we will find one of the angles that the question is asking us. Question asking us for AOC, and since BOD that we just found is vertically opposite of AOC, that's why they're going to be equal to one another. We can find them easily. What about BOD? Where's BOD? BO and D. BO and D. We already found that, right? Now let's do practice number 5. Practice number 5. It says that in the figure AOB and COD are straight lines. Find the value of A and B. Find the value of A and B. Look at this. First of all, take a look at the question, okay? First, understand what the question is. Then it will be really easy for you to know the answer. Since they are straight lines, then that means this is vertically opposite to this. That means these two expressions are equal to one another according to the rule that vertically opposite angles are equal. So we're going to say 3A plus 4D is equal to A plus 60, okay? And that's how we will be able to find the value of A. We know that value of this is exactly equal to this one, right? So if this one is 4B plus 10, then this one is also 4B plus 10. Now if I say these two are equal to one another, I won't be able to solve the question through that method. So I need to use one more thing. I need to take CD as my straight line. Since CD is a straight line, then that means sum of all the angles on CD are going to be the same, and that means A plus 60 is going to be equal to... Okay, now take a look at these two angles. They are on a straight line, right? Straight line, which straight line? CD. They are on a straight line, and that means their sum is going to be equal to 180. What does that mean? That means this A plus 60 plus 4B plus 10, when I add them all together, I will get equal to 180. Now I'm going to do it properly like this. Okay, first of all, we know that, just ignore this for now, focus on this one. I said 3A plus 40 is equal to A plus 60. 3A plus 40 is equal to A plus 60. Okay, why? Look at this. They are vertically opposite angles. That's why they're equal to one another. 3A plus 40 is equal to A plus 60 because they're vertically opposite to one another. I showed the equal sign here. Okay, now I'm going to solve this equation further. We have a variable term, we have a constant term, we have a variable term, we have a constant term. So we're going to make sure that the variable is on one side and the constant is on the other side of the equation. We do that and we will get the value of A. Once we get the value of A, we can easily find the angles as well, but that doesn't matter because the question asks us to just find the value of A and B. How are we going to find the value of B? Now, if I say that 4B plus 10 is equal to 4B plus 10, which in this case, because they're vertically opposite angles, then I won't be able to solve this question, okay? I mean, if I apply this method that we use to find the value of A to find the value of B, we will fail. Why? Because it will say that B is equal to B, and that doesn't really solve the question, okay? So what are we going to do instead? We're going to find the value of B by using the sum of a straight line, right? Sum of them is going to be equal to 180. And now, since I know the value of A, which is equal to 10 that I just found, I will be able to put the value of A in the sum, and I will easily be able to find the value of 4B. What did I do? I first found what this angle is. A plus 60 is going to be equal to 10 plus 60, which is equal to 70, because the value of A is 10. So A plus 60, this angle is basically 70 degrees. Okay, this angle is basically 70 degrees. So 70 degrees plus this angle is going to be 180 because they're on a straight line. So 4B plus 10 plus 70 is going to be equal to 180. Okay, 180 is equal to 70 plus AOD. What is AOD? AOD. I basically did it through this one. I basically did it like this. I know the value of A plus 60, which is 70, and I don't know this angle, right? AOD. But I know the sum of all the angles on a straight line is going to be 180. So whatever this angle is plus 70 is going to give me the answer. So what am I going to do? I'm going to subtract 70 from 180. Okay, I will get the value of AOD, which is equal to 110. And we know that AOD is equal to 4B plus 10, just like we did here. AOD is equal to 4B plus 10. That's why we're going to say 4B plus 10 is equal to 110. So minus 10 from both sides of the equations, we will get 4B is equal to 100. And when you divide 4 on both sides of the equations, you will get the value of B, which is equal to 25. Okay, I was able to easily find the value of B using the basic few rules that I have. Okay, in this whole exercise, these few rules are going to be important. We're going to use the definition of complementary angles, supplementary angles. We're going to use the definition, we're going to use the rule that says that sum of all the angles on a straight line is 180. The rule that says sum of all the angles around a point is 360. The rule that says vertically opposite angles are always equal. Okay, these few things are really important for us to solve any and every question in this exercise. Okay, first of all, this first question is your homework. You can easily do this using a protractor to measure and write down the value of each of the following unknowns. Okay, if you know how to use this tool, you will be able to easily do this question. Okay, write down these questions in your notebook. So you're going to use a protractor to find the missing angles. You can easily use it to measure the angles and find values. You're going to do this in your notebook. Okay, this is your homework. Then you have question number 2. Again, this is your homework because it's really easy. Just take a look at this. It's more than 90, so obviously it's going to be obtuse. It's more than 180. It's more than 180. Look at this. Yeah, it's acute on this side. On this side it is acute, but on the outside it is more than 180. That's why it's going to be reflex angle. And this one is less than 90. That's why it's going to be acute. Okay, so this one obtuse, acute. You can easily tell what these are just by looking at the definition of acute, obtuse that you can find here, page number 166. Okay, so do this. It'll be your homework. And do this in your neat notebook. Okay, then we have question number 3. I did 2 parts, and the 2 parts will be your homework. I'm going to show you how to solve question number 3. Okay, it says that we have what? Complementary angles. And what does complementary angle means? Complementary angle means the sum of them is going to be 90. Okay, the sum of them is going to be 90. Take a look at question number 3. That means complementary angles means sum is going to be 90. So whatever the 2 angles are is going to be 90. One of the angle is given. We need to find the second angle. In other words, what am I going to add with 18 that the sum is going to be 90? What am I going to add with 46 that the sum is going to be 90? And what am I going to add with 53 that the sum is going to be 90? Okay, I did part A here. 18 plus x is going to be equal to 90. In other words, if I just rearrange this linear equation, I will be able to say that x is equal to 90 minus 18, which will give me my answer. So 72 and 18 are complementary angles. The question tells us to find the complementary angle of 18. I did. What is the complementary angle of 18? It is 72. Then in part B, we have 46. 46 plus what number will give us 90? So once you solve this linear equation, you will get the value of x is equal to 44. In other words, once you add 46 plus 44, then you will have 90, and that means 44 is the complementary angle of 46. Okay, similarly, what you need to do in these two parts remaining that are your homework, you need to subtract it from 90 to find the missing angle. Okay, it's not the missing angle, the complementary angle. Yeah. Then again, we have a very similar question here. Instead of 90, we're going to use 180 here because we're using supplementary angles. Supplementary angles means the sum is 180. Supplementary angles means sum is 180. So what am I going to add with 36? What am I going to add with 36? That's going to make 180. I just made an equation, linear equation, and I solved it. I got the value, which is 144. And that means 36 and 144 are supplementary angles for each other, okay? In other words, if I add 36 with 144, I will get 180. So do the same for the rest. What am I going to add with 12? That will give me 180. So what am I going to do in these questions? I'm going to take 180 and I'm going to subtract these numbers from it to find the supplementary angles. That's going to be your homework. Okay. Then we have question number 5. I'm going to do two parts. I'm going to do part A and part B. C and D will be A and B is your homework. Yeah, A and B is your homework. I will do C and D, which are difficult, or maybe it will be difficult, who knows. Okay, first of all, the question tells us what? The question says AOB is a straight line. So find the value of the unknown in each of the following figures. Okay, first of all, I'm going to do part C. AOB is a straight line. Take a look at this. AOB is definitely a straight line. It has these angles here. We have 4C, we have 80, and we have C. Okay, we have 4C, we have 80, and we have C. What do we know about a straight line? We know that sum of adjacent angles on a straight line is 180 degrees. This is the rule. And since AOB is a straight line, then that means all the angles on it, when we add them together, we're going to get 180. That's exactly what I did. See, first angle is 4C. So 4C plus 80 plus C. Okay, all three angles are being added and their result is 180, just as the rule says. Okay, so now I have my linear equation. 4C will be added with C will give us 5C plus 80. Now subtract 80 on both sides. I will get 5C is equal to 100. Divide 5 on both sides and I will get the value of C. Easily. So simple. It's a very basic level of linear equation, okay? But you do need to understand what linear equations are for you to be able to solve the questions of this exercise, okay? Now, part D, it says an entire, it gives us an entire expression as an angle, and it gives another expression as an angle as well. But we know that their sum is going to be 180. We know their sum is going to be 180. How do we know that? Let's take a look at this. AB is a straight line, and the sum of angles, there are two angles on AB. There are two adjacent angles on AB, and their sum is going to be equal to 180 according to the rule. What did I do? I took this angle, I wrote it here, and I added it with the other angle. Okay, exactly the same. But since there is no multiplication here, there is no multiplication at all. There's simple addition going on. That's why I just simply removed the brackets. Okay, I remove the brackets. I get 4D plus 16 plus 2D plus 14 is equal to 180. Now 4D will add with 2D because they're same variables, and 16, 14, which are constants. Add them together, you get 6D plus 30, which is equal to 180. Now this is a simple linear equation. Solve it further. You will get the value of D, which is equal to 25. It looks difficult, but it is really very simple. Okay, this exercise is entirely much more simple than what we did in linear equations. Question number 6. Okay, part A is your homework. I'm going to do part B for you. Okay, part A is also very simple. I'll just tell you what to do. Since we know that A, X, Y, Z are on a straight line, right? The question tells us that X, Y, Z are on a straight line, and that means their sum is going to be equal to 180. Their sum is going to be equal to 180. In other words, X plus Y plus Z is going to be equal to 180. This stands the same for part A of this question. Okay, so what are we going to do? We're going to replace Y with its value, we're going to replace Z with its value, and you will easily be able to find the value of X. Okay, what are we going to do in part B? In part B, it says that X is equal to 2Y and Z is equal to 3Y. I'm going to just put the values. I know that X plus Y plus Z is equal to 180, and I know X is equal to 2Y, Z is equal to 3Y, so I'm going to replace X with X's value, and I'm going to replace the Z with Z's value. Putting the values, I see that 2Y plus Y is equal to 3Y. 2Y instead of X, Y comes down as it is, and Z Instead of z, we're going to put its value, which is 3y. Okay, now since they're all same variables, they're going to add with each other and going to give us 6y. 6y is equal to 180 degrees. Y is going to be equal to 180 divided by 6, so that we can find the value of y, which is going to be equal to 30. It was just as simple as that. There's really nothing more complicated in this question. Okay, question number 7. I'm going to leave you guys to do part A and B. They're your homework. We're going to deal with part C and D. Okay, this is very similar to part 6 that we just did and part 5. There we had a straight line and the sum was equal to 180. Here we have a point, and what was the rule about a point? The rule about a point was the sum of angles at a point is 360. So sum of all of them, sum of all of these, and sum of all of these, sum of all of these, they're all going to be 360, and that's what we are going to use in this question. Okay, part A and B are your homework. I'm going to do part C and part D. Okay, let's take a look at part C for now. Okay, first we have how many angles? Count them. 1, 2, 3, 4. 4 angles. One of them is 90, the other one is 4c, the other one is also 4c, and the other one is 16c, right? So we're going to add them all together. 16c plus 4c plus 4c plus 90 is going to be equal to 360. All of them are c. They're going to add with each other out. So 16c plus 8c, I added 4 with 4, which gives us 8. Then 8 plus 16, 24c plus 90 is going to be equal to 360. Okay, now 90 is a constant. It will go on the other side of the equation. So this plus will become minus 360 minus 90 will give us 270 degrees. So basically 24c is equal to 270 degrees. Yeah. Now divide 24 on both sides of the equation to find the value of c, which is equal to 11.25. Now why did I write the answer in points? Basically in angles it is easier for us to deal with decimals than with fractions. Okay, if I tell you to draw 11.25, you will be able to make an angle of 11.25. But if I tell you to draw an angle of 1 by 2 or 1 by 8 or 5 by 8, it can get unnecessarily hard to understand. This is much more simple to understand here. That's why we're going to use decimals to signify angles when we're talking about degrees. Okay, part C was easy. Part D, again, take a look at the question. We have 1, 2, 3, 4. We have 4 angles, and we know that their sum is going to be equal to 360. So what am I going to do? I'm just going to write them down. I'm going to add them, and I'm going to say their sum is 360. First, I wrote this angle 6D plus 139 plus 5D plus this expression, which is going to be equal to 360. Now again, we don't have any multiplication going on. It is just simple addition, so we don't have to worry about the bracket at all. Just open it without a problem. Okay, I'm going to write all the variables first. These are the variables. D, and it's going to be added with one another, which is going to give us 18D plus 162, which is the sum of 139 plus 23. Okay, then we're going to subtract 162 on both sides to get 18D alone on this side of the equation. Then we're going to divide 18 on both sides to find the value of D. Okay, this was also very simple. Okay, that was our question number 7. I'm going to do question number 8. Yeah. Okay, question number 8 says AOB and COD are straight lines. If angle AOE is 90 degrees and BOD is 45, then find AOC and DOE. Okay, first of all, let's analyze what the question tells us. The most important thing is that we have 2 straight lines. And whenever we have 2 straight lines, then that means we can use vertically opposite angles, which are always equal. Okay, so take a look at this question. Okay, take a look at this question. Is basically the most important thing that you need to understand here is this. As long as you understand the figure that is given in the question, these questions will be really easy for you. First of all, AB, this line, this is straight, and the other one is this line. Okay, so these are straight. In between them we have this angle 48. Okay, so if this one is 48, then the opposite angle here is this one, which is going to be 48. What is this angle's name? It's AOC. So just by knowing the definition, just by knowing this rule, vertically opposite angles are always equal. Just by knowing this rule, I was able to easily find the first part of this question. AOC is equal to 48. Why? Because AOC is equal to BOD. What is BOD? BOD, this angle. BOD, it is already given in the question that BOD is 48. BOD is 48. And AOC is equal to BOD. Why? Because they are vertically opposite angles. Now part 2 of this question. We need to find DOE. What is DOE? First focus, okay? DOE is talking about this one. This DOE, okay? Forget about the rest of the figure. Focus on DOE. Do we know DOE? No, we don't know DOE. But we know that AB is a straight line, right? And sum of all the angles on a straight line is 180. What does that mean? We know this angle, right? It's 90. And we know this angle as well, which is 480. Only one of them is missing. So it's really easy for us to find it. What are we going to do? Let's take AOB as our straight line. Okay, I took that as our straight line. Angle AOB is 90. Angles on AOB. Okay, there are 3 angles on this straight line. There are 3 angles on this straight line. One of them is 90, the other one is 45, and the other one is missing, which is our question, okay? Which is our required. So I'm going to add them all together, and their sum is going to be 180 because sum of all the angles on a straight line is 180. So 90 plus 45 is going to be 138. Sorry, 90 plus 48 is going to be 138 plus DOE, which is going to be equal to 180. DOE is equal to 180 minus 138. I just subtracted 138 from both sides of the equations, and I found the value of DOE, which is required in the question. You need to really practice these type of questions, and again, naming of angles, you should practice that. It's important. Now going towards question number 9. I solved both parts of this question number 9. First, take a look at the question. Okay, given that AOB and COD are straight lines, find the value of the unknown in each of the following figure. Okay, this is our first straight line, AB, and this is our second straight line. Okay, we know that vertically opposite angles are equal, so that means this angle is going to be equal to this one. Since this one is 117, then this one is also going to be 117. So basically 117 is made up of it is made up of 30 and it's made up of 40, right? If I add A plus 30 plus 40 is going to give us 117. How do we know this is 117? Because they are vertically opposite angles. So I know that A plus 30 plus 40 is 117 because they're vertically opposite angles, and A is going to be equal to 30 plus 40, 70. Okay, so we get A is equal to 70, which is equal to 117. Now minus 70 on both sides, I will get the value of A. It was really easy to find the missing variable. That's it. There's only one missing unknown number here. That's A. Okay, in question number B, we have 2 missing variables. We have we have B and we have C. Now, the information given to me in here isn't really that much, but it's totally enough. First of all, 2 straight lines. I have 2 straight lines. From the first part, I am easily able to tell 7B is equal to C. Why? Because they're opposite angles, vertically opposite angles. Okay. And one more thing. Let me show you this. Yeah, AB is a straight line, right? And the angles on AB we have is 7B and 3B. Then that means the sum of 7B and 3B is going to be equal to 180. That's exactly what we did here. First, to find the value of B, I added 7B plus 3B, which is going to be equal to 180 because they are adjacent angles on a straight line, AB. Okay. If I add them together, 7B plus 3b is going to make us 10b. 10b is equal to 180, and divide 10 on both sides of the equations, I will get the value of b, which is equal to 18. Once I know the value of b, I can easily find the value of c. Why? Because take a look at this. 7b is equal to c. They are vertically opposite angles. So 7b is equal to c because they are vertically opposite angles, and opposite angles are equal. So we know that we know the value of b. I'm going to just put the value of b in this equation, and I will easily be able to find the value of c. C is equal to 7b, so 7 multiplied with 18, it will give me what c is. Okay. Now, question number 10. Now, question number 10 says that x, y, z are 3 angles lying on a straight line. What does that mean? That means the sum of x, y, z, whatever they are, their sum is going to be equal to 180. That's it. Their sum is going to be equal to 180. That's exactly what we need to know. Since x, y, z are on a straight line, then that means their sum is equal to 180. So What does part A tell us? Part A says that y is equal to x plus z. Y is equal to x plus z. We need to find the value of y. Take a look at this. We know that x, y, z, the sum of x and y and z is equal to 180 from the question. Since they're on a straight line, their sum is equal to 180, right? I just rearranged it, okay? I put the y, I put z in instead of y and took the y to the end of this algebraic expression. So x plus z is plus y is equal to 180. The same thing, they're both the same thing. I just rearranged it. Why did I rearrange it? To show this. Okay, we know that y is equal to x plus z. We know that y is equal to x plus z. So instead of this x plus z, what am I going to put? I'm going to put y. And y plus y is equal to 180. Y plus y means 2y is equal to 180. Now divide 2 on both sides. I will easily be able to find the value of y, which is 90. Okay, now I have B part. In B part, question says x, y, and z. They are all equal. We know that from the question, we know that x, y, z are on a straight line. That's why their sum is 180, right? So what are we going to do? We're going to just write the same thing as we did here. The sum of x, y, and z is 180. Now instead of y, I'm going to write x because they're equal. And instead of z, I'm again going to write x because they're all equal anyways. If x is 8, then y is going to be 8 and z is going to be 8. Doesn't matter, they're all equal. So why did I... The question basically tells us to find the value of z, not x, right? The question tells us to find the value of z. So I have a choice here. I can take all of them as x, or I can take all of them as z, or I can take all of them as y. Anyways, it just doesn't matter because since all of them are equal. All of them are equal. So if I find the value of x, that also means this is the value of y, and this is the value of z, because they're all equal anyways. I just took it as an x for now. 3x plus x means 3x, and 3x is equal to 180. Divide 3 on both sides of the equation. I will get the value of x easily. Now, I chose x just because I wanted to. Doesn't really matter. You could have chosen z or you could have chosen y. The thing is that you're going to take the same variables. Why? Because they're equal, okay? So it doesn't really matter what you write here. You should be able to add them because they're equal. Once you find the value of x or y, you can just convert it into z by saying that they're equal anyways, according to the question. Now we're going to do question number 11. Read the question and try to understand it, okay? Now, here it says that DOB is a straight line. First, let's check that out. DOB is a straight line. Take a look at this. DOB is a straight line, okay? DOB is a straight line. And what does it says? Question says angle BOC. What is BOC? BOC. It's talking about this angle. This is twice of AOB. AOB. It's talking about this angle. Okay? Twice of AOB. And COD means this angle is 4 times of AOB. 4 times of AOB. Okay? Then it says that, look, all the angles are being described in terms of AOB. Angle BOC is being described in terms of AOB, COD is also being described in terms of AOB, and DOA is also being described in terms of AOB. That's why we took it as the most basic term and I gave it a variable. Let's say this angle is equal to A. Then this one is going to be 2A, this one is going to be 4A, this one is going to be 5A. Okay, I got this information from the question. And the question tells us to find all of the 4 angles. Okay, first of all, they are around a point. They are around a point, and that means the sum of all these unknown angles is going to be equal to what? 360. Luckily, they're all the same variable, so we can easily add them. Okay, take a look at this. Sum of all the 4 angles is going to be equal to 360. What are the 4 angles? I wrote the name of all the 4 angles, okay? You can take a look at them. You can tell what I wrote. AOB, first AOB, then BOC, then COD, and then AOD. All 4 angles. And let's just say if AOB is A, let's say if AOB is equal to A degrees, then BOC is going to be 2 times of that, and COD is going to be 4 times of that, and AOD is going to be 5 times of that. This information is given right in the question, okay? So I'm just going to replace the names with their values, which is A plus 2A plus 4A plus 5A, okay? Since all of them are A, we can add them together and we will get 12A. Once I'm able to find the value of A, then I can just put the values in back. We know that AOB was equal to A, then that means the value of A is going to be the value of AOB. And if I multiply it with 2, I will be able to find the value of BOC. If I multiply it with 4, I will be able to find the value of COD. And if I multiply it with what? 5. 5 multiplied with A is going to give me the value of AOD. All 4 angles, we easily found them by finding the value of A. Okay? Now in question number 12, I am going to do the first part, and I'm going to do part number D, while B and C will be your homework. Okay? First, take a look at the question. Question says that AOB and COD are straight lines in all of these parts, okay? All the parts of question number 12, in all of them, we will have a straight line AB and CD. They're straight lines, okay? Whenever you have two straight lines, just take a guess, okay? What are we going to use? We are going to use vertically opposite angles there. For sure, we will use them, okay? Whenever you have two straight lines intersecting with one another. Okay, find the values of the unknown in each of the following equation. In this equation, what is unknown? B is unknown and A is unknown, okay? We have the unknown B and we have the unknown A. How are we going to solve this? First of all, take a look at these two angles. They are vertically opposite to one another, and that means they are going to be equal to one another. So I can easily find the value of B. I can easily find the value of B. How? By taking them equal. So I said, take a look at this, right? 2B plus 13. 2B plus 13 is equal to 103. Why? Because they're vertically opposite angles, and vertically opposite angles are equal. Then I have my equation, a very simple linear equation. This is, you just have to simplify it further to find the value of B. Okay, solve it and you will get the value of B. Once you have the value of B, you can easily find the value of 7A as well. How? Take a look at this. Yeah, angles on a straight line. What do we know about them? Angles on a straight line, their sum is going to be equal to 180. We have two angles on this straight line, this and this. Since I know the value of B, I can find whatever this angle is. And we don't know the value of A, I can find the value of A. So, first of all, 2B plus 13. I will find its value. Or, I have one more method of solving this question. Take a look at this. Again, a straight line, right? And sum of all the angles on a straight line is 180. So that means 7A plus 103 is going to be equal to 180. That's what I did here. 7A plus 103 is going to be equal to 180 because they are on a straight line. It's very easy. I can just subtract 103 on both sides of the equations. I will get the value of 7A and then divide 7 on both sides to find the value of A. That's it. The two variables that were unknown, I was able to easily find them. Now, question number D looks difficult, but it's also very simple as long as you are able to identify what are the straight lines and what are the vertically opposite angles and stuff like that. Okay, first of all, this is our straight line. We have a CD as a straight line, okay? CD is our straight line. Then, take a look here. We have AB. AB is our straight line. And that means whatever J is going to be equal to 2I because they are vertically opposite angles, okay? J is going to be equal to 2I because they are vertically opposite angles. Now, we're going to first find the value of I. How are we going to find the value of I? Take a look at this. When one angle, two angle, three angle. Only one of them has a variable here. And they are all on a straight line. Straight line, which straight line? A, B, okay? They're on a straight line and their sum is going to be equal to 180. So in other words, in simple words, 2I plus 104 plus 32 is going to be equal to 180. Okay, we got this from the question. They're all on a straight line, that's why their sum is going to be equal to 180. Now constants are going to add up to one another. We got, wait a second. Oh yeah, sorry, this was 136 and this one is 136, and when you subtract them you get 44. The rest of it is right. There isn't a problem with the question. Yeah, we just have to subtract 136 here as well. Yeah, okay, fine. First we add them together and we get 136, and when we subtract that from 180 we will get the value of 2I. Divide 2 on both sides, we will get the value of I. I is equal to 22, okay? And 2I is equal to 44. 2I is equal to 44. Now what did I say? I said J is equal to 2I because they're vertically opposite angles. Then I can find the value of j. J is equal to 2i, which is equal to 44, which is because they are vertically opposite angles. I found the value of I found the value of j. Now I need to find the value of h. How am I going to find the value of h? Now take a look at this. We're going to use, again, there are different methods of how I can find the value of h. For example, since I know the value of I know the value of I know the value of j, I can put their values and find these angles. I also know this one is 90, so I will know every other angle except h. That means I can add all the other angles and I can subtract them from 360. I will be able to find the value of h. But I used a much simpler method. Simpler method would be to take it like, I can take, which line should I take? Should I take this one? Okay, fine. You tell me. See, we have, look at this, CD is a straight line, and on the CD we have 1 2 3 4 different angles. We have 4 different angles. Okay, you can also take this line, or you can take AB as your straight line. Now take a look at this. We have H, we have 90, we have 24, and we have J. We know the value of J, which is 44. So instead of J, I can write 44. So we know 44, 24, and 90, and H. And their sum is going to be equal to 180. That's what I did here. H plus 90 plus 24 plus J is equal to 180. And we just put the value of J. We're going to add 90 plus 240, which is going to be equal to 24. 24 is going to be equal to 114 plus 44. H is equal to 114 plus 44. When you add them together, you get 158, which is equal to 180. And you can find the value of H pretty easily, which is going to be equal to 22. Sorry. Yeah. The value of H is going to be equal to 22. You found the value of I, you found the value of J, you found the value of H. These were all the missing variables in this part. It is still much more easy as long as you do understand the rules. Now we're going to deal with the last questions of this exercise. Question number 13. Let's first read the question. Question says AOB and COD are straight lines. Find the value of x and y and find obtuse AOD and reflex COE. Now this is where it gets interesting, okay? Find the value of x and y. How are we going to find the value of x and y? Take a look at the question. Since A, B, and C, D are a straight line, then that means we have vertically opposite angles here, right? Basically, it means that this vertically opposite angles, which is 6x, is going to be equal to the sum of this entire two things, okay? In these two angles, their sum is going to be equal to 6x, and that's what we took here for the first part. We said 6x is equal to 34 plus 186 minus 4x. These two angles, they are equal to 6x because they're vertically opposite angles. Then I can just simplify this. Okay, the only variable in this question we have in this equation is x. So I can easily find the value of x. Again, we don't have any multiplication going on or anything other than addition. So it's really simple. We can just open the brackets and add the constants. Then make sure that the variables are on one side. I'm going to add 4 on both sides of the equations, and then I'll get 10x. 10x is equal to 220. Divide 10 on both sides and I'll get the value of x. Once I get the value of x, then I can simply show you to a straight line. Look at this. We have a straight line. We have two angles on it. One is 6x and the other one is 3y. Since I know the value of x, I can find this angle pretty easily, and I can find the value of y through that. Okay, so first we say 6x plus 30y is equal to 180 because they're the angles on a straight line, right? They're on a straight line. That's why their sum is going to be equal to 180. 6x plus 3y is going to be equal to 180. I put the value of x in place of x, and I get 6 multiplied by 22, which is going to give us 132 plus 3y, which is equal to 180. Now subtract 132 from both sides of the equations. I will get the value of y, which is going to be equal to 16. Okay, AOD. That's the second part of the question. Question tells us to find AOD. Where is AOD? First, where is AOD? AOD. Let me show you. This is AOD. This is AOD. AOD is made up of two angles. AOD is made up of 34 and 186 minus 4x. These two angles, when they combine, when we add them, we get AOD. That's exactly what we did here. AOD is equal to 34 plus 186 minus 4x. Since we know the value of x, we can easily put it and find the value of AOD using this expression. But in the first part of this question, we were able to say that the same expression is equal to 6x. Then it is much more easier for me to just take it as 6x, which is equal to 22. Okay, 6x is equal to 22, and AOD is going to be equal to 6 multiplied with 22 is going to give us 132. Okay, I basically used this. Since AOD is equal to this, and since this is equal to 6x, that's why I'm just going to put the value of x in this small term to find the value of AOD. Okay, you can also find the value of AOD by just putting the value of x here. Still would be the same. Okay, we have COE here, right? We need to find COE, not just COE. Look, if you take a look at COE, where is COE? We have C, O, and E, right? C, O, and E. Now, if you look at this, this is an acute angle. This is an acute angle. The question specifies that it's a reflex COE, and that means our angle that the question is talking about is everything excluding the COE. Okay, it's going to be from the outside, and that means this whole turn. Okay, we need to find that. This whole turn is made up of 6x plus 3y plus 186 minus 4x. If we add all of these three angles together, we will be able to find the reflex COE. That's exactly what we did. Okay, 6x plus 3y plus 186 minus 4x. They are simple addition here at this point. We just have to add them together. We have to simplify it further. X will interact with x. There's nothing for y to interact with, so it will come down as it is, and the constant will remain the same. Now, since we know the value of x and we know the value of y, we're just going to put the value of x and y to find the reflex angle. Okay, the reflex COE, and its value is gonna be equal to 278. This is it for our first exercise of chapter number 10. We'll do the rest later. Okay, now one more thing that you need to know is that unfortunately, due to the parent-teacher meeting, we won't be able to hold a discussion class on Sunday. So you can write down your questions and your feedbacks on a piece of paper, and we can discuss them later on Monday then, inshallah.